In this video, we're just going to look at connecting a motor to the Arduino, so allowing the Arduino Nano to control a DC motor, bi-directional control. So that means controlling the movement of the motor in two directions. So before we learn how to interface those two together, let's just look at the motor on its own and connect it up to the battery pack to see what it does. So the battery pack that I'm using here is a 4AA battery pack, so that's 1.5 volts per battery, and they're all in series, so 6 volts altogether. The battery pack that I'm using also has an integrated power switch here. This is the motor that we're going to be using for this example. It's a geared DC motor, so at one end of it has a small DC motor which can be driven in either direction, but it also has a gearbox built into it which has a gear ratio of 120 to 1. So that means that every 120 times that the motor revolves, the spindle of the motor here is going to turn once. I've stuck on a little wheel onto the shaft of the motor here just so that we can see it moving more clearly, and I've put a bit of tape onto the wheel just so we'll be able to see the turning clearly when we get to that point in the demonstration. So to connect this to the battery pack, I'm going to use the breadboard here, and I've already got two wires soldered onto the terminals of the motor. So I'm just plugging them into two empty rows on this breadboard, and then I'm going to connect the red and black wires of the battery pack into the same rows. And we'll just see what happens when I switch on the power on the battery pack here. So you can see in this case the motor is turning in anti-clockwise direction. So first thing to notice is that if I swap the two battery wires around to reverse the direction of the current through the motor, what you'll notice is that the motor is now turning in a clockwise direction. So the direction that the electric current flows through the DC motor will control the direction of rotation of the motor. So that's the first thing. You can actually try doing that with the motor yourself, just to verify that the motor is working, that the battery pack is working, that you're able to switch on and off the power, that your batteries aren't flat, and so on. Okay, now what we really want to do is to be able to use the Arduino, which is this microcontroller development board here. This is an Arduino Nano. We want to use this, or program running on this, to control the movement of the motor. Now one thing, the Arduino is a very flexible and adaptable component, but one thing it doesn't do is it can't supply large electric currents through its I/O pins. It's limited to, I think, 40 milliamps, I think it is, per pin, or it could actually be less than that. Maybe it's 20 or 25 milliamps per pin. So that won't be enough to drive the motor directly. So we need to use an additional component, which we're going to be using this driver chip here, which is an SN754410 NE. And this is a driver chip produced by Texas Instruments, and we'll see the datasheet for this in a minute. We're going to use this to interface between the Arduino and the motor. So basically, let's take a look at what the circuit is going to be like first. Just move these to the side. I'll draw out the circuit on paper. So I'll draw the main blocks first, and then I'll show how they're connected together. So I suppose the star of the show here, as usual, is the Arduino. So let's just represent that with a rectangle here. Then I'm going to draw that other chip, the driver chip, which is going to interface between the Arduino and the motor. I'm just going to represent that as a rectangle as well. And for this demonstration, I'm going to have the one DC motor over here. So the symbol that we use for a DC motor normally is just a letter, capital letter M, in a circle with two sort of terminals on it, like this. The circuit is going to be powered from a battery pack. So in some simpler circuits where you've only got light electric loads like an LED or a couple of LEDs, it's sufficient to draw power from the USB socket of the computer. But that won't work for a circuit like this, because we're going to need more substantial current than the USB socket can supply. So that's why we're using the battery pack here. And the battery pack is going to be represented by this symbol here, which is the symbol for a DC voltage source. And I'm going to extend the connection from the positive terminal of the battery pack all the way over here, and I'm going to connect that to two pins on the driver chip, and we'll see on the datasheet in a minute which pins I'm actually connecting to there. The black wire of the battery, which is the negative terminal, is going to connect all the way over here. This is actually going to connect to 4 different pins on the driver chip. Again, we'll see on the datasheet in a minute which pins these are. So I'm going to connect 4 of the pins from that driver chip down to my negative rail. So this is connected back to the negative terminal of the battery. So because it's 4 AA batteries, it's a 6-volt DC source. The Arduino, of course, will also need power connections. So I'm going to connect the ground pin of the Arduino to my negative rail here. So this will actually be the blue rail on the breadboard, but it's connected back to the negative terminal of the battery pack. And I'm also going to connect the 5-volt pin of the Arduino to the positive rail. So this whole rail up here is going to be 6 volts. That'll be the red rail on the breadboard. What else have we got here? Now I'm also going to include in my circuit a capacitor in order to smooth the voltage supply. One of the things that you'll find when you work with motors is that they're quite inductive electric loads, which means that when you make sudden changes to the current flowing through them, it can give rise to voltage spikes in the circuit. And one of the ways that we can help reduce the impact of those spikes, which might disrupt the operation of the Arduino, is to put in smoothing capacitors. They act as a kind of a buffer for electric charge, so that when there's sudden changes in the demand for electric current in the circuit, they tend to kind of buffer the electric charge available on the supply rails, and it'll tend to dampen down the kind of the worst effects of those voltage spikes. So the capacitor that I've used in this circuit is quite a large one. It's a 220 microfarad capacitor. This is actually what it actually looks like here. Let me just get that in focus. So you can see it's a little kind of cylindrical component. The value is written on the side there, 220 microfarads. It's got 2 legs on it there. I've trimmed down the legs on the one that I'm actually using in the circuit just to get it down close to the surface of the breadboard. But that's what it looks like. Also, this is a polarized capacitor. So one of the legs is marked with a minus sign indicating the negative leg. So this will be connected to the 2 rails on the breadboard, and I need to make sure that the negative terminal of the capacitor is connected to the ground rail, the 0-volt rail. Okay, so back to our circuit. Now, I'm also going to add into this circuit, before I show the actual motor connections, for the purpose of just testing things initially in the program that we're going to write for this, I'm going to add in a simple LED circuit here. So this is just an ordinary visible LED in series with a current limiting resistor. 220 ohms is what I'm going to use here. And this will just allow us to test that the Arduino is running correctly and that we have power to the circuit. So I'm going to put that on the digital I/O pin D2. And that's the first thing that we're going to test before we even try and switch the motor on and off. Okay, so let's have a look at the pins of this driver chip here by looking up the data sheet for it. So this will enable us to figure out which pins are which. So the name of this chip is SN754410 and it's made by Texas Instruments. So let's have a look at how we're going to look up a data sheet for a chip like that. So just go to Google. I'm going to type in the name of the component, SN754410 NE, and the word data sheet. What we're going to be looking for here is search results that are PDF documents. And in particular, ideally we get one from the manufacturer's website. So you can actually see this is ti.com, that's Texas Instruments, and you can see that it's a PDF result. So this is almost certainly what we're looking for. So they describe the chip here as a quadruple half H driver. I won't get into exactly what that means, but you can use the channels here to form what they call a H bridge, which will facilitate bi-directional control of an electrical load like the motor that we have here. What we're going to be most interested in though here is the pin out, which is the diagram of the chip which shows which pins are which. And you can see a table identifying the pins down here, but also like a visual map of the pins up here. One of the things to look for in the pin out or the pin diagram is that there is a notch illustrated at the top end of this chip, a little semicircular notch. Now if I just show you this on the camera, let me find my way back to the camera here. You can actually see that notch at the top end of the chip there. So that identifies the end of the chip where pin 1 is going to be found. So the pin diagram in the data sheet is basically looking at the chip from the same perspective that we're looking at it from here. So back to our pin diagram. You can see that the two middle pins on each side of the chip are heatsink and ground. So we're going to ground all 4 of those pins, which means that we're going to connect all 4 of them to 0 volts. And then there are 4 driver channels. So each driver channel has got an input pin, which can receive a signal from something like the Arduino, and an output pin, which can deliver current to some sort of electrical load, like a motor. So we're going to use 2 of these channels. We're going to connect the motor to the 2 outputs of two of these channels, and we're going to control the 2 channels with signals coming from the Arduino. Now I think actually in my example circuit I'm going to choose channels 3 and 4, but it's arbitrary really. You can choose any 2 channels to control your motor. I'm just going to use 3 and 4 because it suits the layout that I'm going to use on the breadboard. The other pins that we need to connect are pins 16 and 8, which you'll see are labeled as VCC1 and VCC2. These are the power supply, positive power supply pins for the chip. So in our circuit, everything's going to be powered at 6 volts. That's the 6 volts from the battery pack. So pin 8 and pin 16 are both going to be connected to the red rail on my breadboard, which is 6 volts. So 4 middle pins will be grounded. These 2 corner pins are going to be connected to 6 volts, which is the red rail. And then I'm going to use channels 3 and 4, both input and output, to connect to the Arduino and to connect to the motor, which is going to be controlled. So let's draw that into the circuit. Let's put in the 4 channels first. So these driver channels are sometimes represented with these kind of like amplifier symbols, these like triangular symbols. But the basic idea is that you've got in each one of these channels a low power input signal which controls a higher power output signal. So the output signal could be at higher voltage, but it could just be that the current is higher. And in this case, the output is basically going to be the same voltage as the input, but the size of the current flowing out of it will be much bigger than the current flowing in. So the Arduino doesn't supply very much power. It's more supplying the information about what the motor should do. And then the outputs of the driver chip are actually supplying power to the motor to enable it to turn. So as I said, there's 4 channels available in this chip. We're only going to use 2 of them for this demonstration. Let's label them 1, 2, 3, 4. So it's channels 3 and 4 that I'm going to use. Let's just remind ourselves what the inputs and outputs are for these. So for channel 3, which is over here, the input is 3A and the output is 3Y. You can see they're identified down in this table here. So 10 is the input and 11 is the output for channel 3. So I'm just going to number them here, 10 and 11. And for channel 4, you can see the input is 15 and the output is 14. And the digital outputs that I'm going to use when I write my program to run on the Arduino, I'm going to select pins D3 and D4 as the 2 outputs which will control the motor. So I'll connect D4 to pin 15 and I'll connect pin D3 to pin 10 on the driver chip. So these are going to feed signals from the Arduino into the driver chip. And these 2 signals here are going to control these 2 outputs here, which we're going to connect to the motor. So let's wire that up here. I'm going to connect a wire from that output pin to one terminal of the motor, and I'll connect another wire from this output pin to this terminal of the motor. Okay, we're nearly ready. Let's think, are we missing anything here? So I've got battery pack, capacitor to smooth the power supply. My Arduino is receiving power from the red rail up here and the ground rail down here. Might as well label this 0 volts down here. I've got my little LED circuit here, which I'm going to use for testing purposes. I suppose I should number these pins here. These are the two center pins on each side of the chip. So that's pins 4 and 5 and pins 12 and 13. And these two pins up here are the corner pins that I mentioned, which must both be connected to 6 volts. So that's pins 8 and 16 on the driver chip. Let's just label this as the Arduino. Okay. So we nearly have everything. I didn't bother numbering the pins here because we're not going to use them, but there are 2 other channels available if you wanted to use them. So let's see what that looks like on an actual breadboard. I'll just move this down a little and hopefully we'll have room to see the 2 at the same time. So just to show you which bits on the circuit diagram correspond to which parts on the breadboard circuit here. Firstly, you can see the Arduino represented by this rectangle here. That's actually the physical Arduino, that blue development board which we have plugged in. The actual microcontroller is just that one chip there. That's the Atmega 328P. So that's the actual single chip computer which is going to be running the program that we write in a couple of minutes, which will control the motor. This chip here is the driver chip. So the SN754410 that's this chip here. And you can see if we look at the wires on this chip, the 4 center pins, as in 2 center pins on each side, are connected together with these black wires here, and they're connected back to the blue rail. So that means that all 4 pins in the center of the chip are connected to ground, the ground rail here. And when I connect my battery pack, the negative terminal of the battery will be connected in here. In fact, I might as well connect the battery pack now so we can see that. So the battery pack will connect to the 2 rails on the breadboard. So my negative wire from the battery pack connects via the black wire to the negative rail here. So that'll be available to the rest of the circuit all the way along the negative rail here. And the red wire from the battery pack, which is delivering 6 volts, is connected to my positive rail. So again, that's available all the way along the breadboard here. Okay, so the 2 center pins on each side are all wired back to the negative rail. So they're all connected to 0 volts. The 2 corner pins, which are pin 16 and pin 8, they're connected together by this red wire and then connected back to the red rail. So they're receiving 6 volts from the battery pack via this rail here. Anywhere that we've got connections which are receiving the positive supply voltage in the circuit, we always use red wire for that, and we should never use red wire for anything other than that. Similarly, black wire is only ever used where you have a ground connection, so something that's connected to 0 volts, and that will always be at 0. So that's why these 4 wires here are black, and why the black wire coming from the battery pack is the same color. The 2 power connections to the Arduino, this red rail here is connecting the 5 volt pin on the Arduino to the red rail. So on our circuit diagram, that's this connection here. This black wire connects the ground pin on the Arduino, GND, back to the negative rail here. So that is this connection here. You can see over here in the corner of the breadboard I have the capacitor plugged in. So that's the 220 microfarad capacitor. And in our circuit diagram, this is the capacitor here connecting between the positive rail and the negative rail. So that's the capacitor here. And my battery pack here, of course, is connected directly to the positive and negative rails. So that's this DC voltage source here connecting to the 2 rails. I have my LED circuit connected to D2 on the Arduino. So you can see on my breadboard I've got a blue wire connecting from pin D2 to the LED. That's this connection here. This symbol here represents the LED, which is this green LED here. And then you can see the other leg of the LED is connected to this resistor, 220 ohm resistor. That's this connection here. There's the resistor, and then the resistor connects directly to the negative rail. So that's this connection here. Okay, there's the 4 ground connections on the driver chip, the 2 corner pins which are supplying 6 volts to the driver chip. You can see I have the motor connected in the diagram here, but it's not yet connected in the physical circuit, so we need to plug that in. So bring back my motor and I'm going to connect to pins 11 and 14. Okay. Try and straighten out those wires a bit so we can see what's connected to what. Right, we're looking good. Now we're almost ready to switch this on. At the moment, I think if I switch it on, we're expecting nothing much to happen because the Arduino isn't programmed yet to do something. So I'll leave the battery pack switched on and I'm going to plug in the USB cable from the PC so that we can upload some software onto the Arduino. Just plug that in there and I have that connected back to a USB socket on my PC. So let's bring up the Arduino program here. So we'll keep this nice and simple at first. Oh, there's something actually flashing. There must be some code running on this already, but we'll replace that now in a minute. So first thing I'll do is just put a short comment at the beginning to explain what this program is. And I'm going to get rid of these default comments here. And let's save this as, we'll just call it motor. So initially I just want to test that LED there, just to check that we're actually running a program on the Arduino. So I'm going to just, it currently looks like it's flashing about once a second. So I'm just going to, or no, it's actually a bit slower than that. So I'm going to just speed it up. So we'll flash it on and off, on for half a second, off for half a second. So in order to control pin D2, which is the LED pin, I need to set the pin mode for pin 2 as output. And then to control the voltage on the pin, I'm going to use the digital write function. So digital write pin 2 high. So that will set the voltage on pin D2 to 5 volts, which means that we will be setting the voltage on pin D2 to 5 will cause current to flow through this blue wire, through the LED, causing the light to come on through the resistor and back to ground in the battery pack here. So that's what this line here is going to do, and I'm going to leave it that way for, well actually first we'll just check that that works. So I'm going to program this onto the Arduino. Now I think in this case, yeah, I'm going to need to select which Arduino I'm using. So under the tools menu, you'll find a sub menu called board. And from this you'll want to select the type of Arduino that you're using. I'm using an Arduino Nano here. There are several different options that you can choose for the specific type of Nano that you're using. The one I'm using has got the Atmega 328P microcontroller and it is loaded with the old bootloader. So I'm going to select that. And then you'll also need to select the port that it's connected to. Now I'm in Linux here, so the ports appear slightly differently than they would in Windows. In Windows they'll appear as COM ports, so it might show up as COM4 or COM5 or something like that. But I'm going to select the way it appears for me here is as USB 0. And that should be it. So I think we're ready to upload. So the upload button is the right facing arrow there. I'll just click that and we'll see if it manages to upload correctly. If the upload is successful, you'll see done uploading appearing here in the message bar. And you can see indeed that the program is now running on the circuit there because the LED is just switched on constantly. So now I'm going to try to control the other pins which are connected to the motor, and we'll see if we can get the motor turning. So I'm going to need some additional digital outputs here. Remember that my two pins that are connected to the driver chip are pins D3 and D4. So I need to turn both of them into digital outputs. And then I'm going to set the voltage on one of them to be high and the other one to be low. and we'll see which way the motor turns. So I'll upload this to the Arduino, and you can see the motor is turning anti-clockwise there. So now what I'm going to do is I'm going to try and swap these around. So instead of having high and low, I'm going to set them low and high, and we'll see if that reverses the direction of the motor. So yeah, there's the motor driving forwards. Now if I set both of the digital outputs low, then those two signals are going to feed into the driver chip low, and then the outputs of the driver chip will both be low as well. So as a result, you can see there's no voltage across the motor, no current flows through it, and it just stops. Just for completeness, I'll show you what happens if you were to set both of these high. The effect is basically that the motor is still going to remain stationary. In this case, the two signals coming from the Arduino to the driver chip are both 5 volts. And the output signals from this chip are also going to be both 5 volts, or well, 5 or 6, because it's been powered from a 6 volt supply here. Which means that there's no voltage drop across the motor, so there's nothing to actually push current through it. In order to drive a current through the motor, you'd need the voltage to be different on the two wires connecting into the motor. So that's basically it. If we want to drive the motor one way, we set it high and low. If we want to drive it the other way, we set it low and high. So there you go, there's it turning there. Now what I'm going to do is, let's just stop the motor for a minute, and we're going to put in a sort of a sequence of movements just to see how we would produce a particular pattern of movement here. So what I'm going to do is set the motor turning one way, and I'm going to put in a delay to allow it to keep turning in that direction for a few seconds. So I'll just put in a 3000 millisecond delay there, and then we'll turn the motor in the opposite direction, this time with the LED off. And I'll do that for, let's say, 2 seconds. And then finally, we'll leave the LED off, and this time I'm going to stop the motor, and we'll leave it stopped for 2 seconds. So let's program this on here, and we should see this sequence of movements happening. So the motor is turning in one direction for 3 seconds, other direction for 2 seconds, and then it stops for 2. Now because these instructions are in the loop function, you can see that after it's completed all of these instructions, it just repeats them over and over again. So you can see that that sequence of movements is just going to continue indefinitely until the power is switched off. So that's a good place to stop.